Usually when a language gets designed, especially historically, many of them are designed in an academic setting, or else some of them come out of a business setting, but for relatively simple problems, And what I was finding was, in games, we tend to hit problems earlier than people in other industries, and in ways that are more complicated, right? And so I actually wanted to design something based on that experience to try to solve the problems that are really hard, because everybody, I feel like there's all these features that go into language design that come from the designer thinking about problems that are actually not that hard, which can be a little bit important if they're constant frictions, but it's not the same as a brick wall that you run up against eventually. So for example, people talk all the time about, it's really important not to leak memory, right? And so you get all of these quite complex systems put into place to make sure that you free your memory or whatever, right? And they impact your performance quite heavily. But what I try to tell people is memory leaks are not actually very bad. I mean, you shouldn't have them in your shipping game, but you can go almost all the way up until ship with a lot of memory leaks. And it's no big deal because you're restarting it all the time anyway, and you never get to the point where it matters. For us, the much harder problem than freeing memory is, when you're a beginner, it could seem hard, but once you're experienced, it's pretty easy. You just if your code's too complicated to understand when you should free the memory, just simplify your code, right? But the hard part is to know how the game should behave, and what should this system be like, and do we need to rewrite this 3 times for it to be the right thing? And so I consider it very important to be able to rough draft your code and treat it as a little bit disposable and not as production code for a long time until you get it figured out. And then you're like, okay, this is the thing that we want. Now let's harden it. Let's make sure there aren't memory leaks. Let's go over all the if statements and make sure that the logic makes sense and all of that, right? And this is where I differ with languages like Rust, for example, which has one of these ways of making sure you free memory, one that doesn't impact performance as much as other systems. But Rust's mindset is that all code is production code. And I think that's deadly because it's so hard to make games that if you slow down the iteration loop by 10 or 15%, both of my previous projects probably would have failed, or they would have been worse games because they were so hard to program. If you make it harder, I can't do it anymore. And so I'm trying to make it easier by looking at the things that are actually problems, right? And the problems are, what are the real problems? I don't understand my program. It's too big and complicated. I don't know what it does. Sometimes when I go to debug it, it takes too long and I don't know what the problem is, right? Sometimes I have to write big systems that are a little bit error prone because the language doesn't have features to help me out. So with C++, that would be, there's no reflection or introspection system, although
natively.
Word is they're going to add it to C++ 26, and I'm sure it's going to be the worst thing ever. But there are real hard problems like this. Or just so I got into programming when I was a little kid. I was 10 years old and computers were so exciting. And I just could type, 10 print hello, and it was so cool. And I made a game when I was in school. Yeah, I was 10 or 11 years old. It was a stupid game, but I made one, and it was so exciting and fun. And now I'm a professional programmer, and programming sucks and is horrible, and it makes me an unhappy person. And I think that's most programmers' experience. That's a problem that we could attack and solve, and everyone's worried about, are you going to free that memory? Yeah. Are you going to free that memory? And it's like, no, what about programming sucks? Yeah. Can we attack that problem? So that's what I'm thinking about. And of course it's difficult. I'm not saying that I know how to make programming fun again. I know how to make it, I know how to get rid of some of the problems. But that's what I aim for, right? Is given that I have a bunch of experience using systems languages, right? So I'm not trying to make a language for non-programmers. I'm not trying to make a language for people who don't want to think about memory, right? It's decidedly a systems language, but like, what are the real problems? And can we move the line on the real problems, even a little bit? Because I don't think that line has moved. Like, C++ was an attempt to improve C and make it better to do better programs. And I think a few things from C++ help, but it's really just a few. Most of the features in C++ don't help at all, and in fact make things worse, in my opinion, again. I don't really use anything after C++ 11, and from the stuff before 11, I don't use multiple inheritance. I barely use templates, hardly at all. I don't use the standard library. Everything now is in the standard library. It's a giant mess that I don't, you know. And I'm not alone in this. There's a subfield of programmers who take a similar attitude, right? And so I'm just trying to say, like, look. So I was talking to Casey Muratori, who some people here may know, and he was saying, you know, if I were to design a programming language today, it would be about managing wavefronts, because the future of CPUs is this massively parallel stuff like you have on GPUs. And I said to him, yeah, that's a good thing to work on, but like, I think we stopped in the 1990s, right? So I'm just trying to make, what should we have made even in 1996? Like, what would have been the next step forward back then? Because I feel that that's for how long that we've been stagnating.